We are looking at chapter number 1, which is physical world. We will be discussing physical world. So what all we have seen in the previous discussions, we learned about the optics, the electricity, the magnetism, motion, force, gravitation, heat, energy, wave, sound, universe. And this we learned under science. But in fact, all these are related to physics. Now, what the first question comes in our mind is, what is physics? So physics is one of the basic disciplines in category of natural sciences. Physics is a science in order to understand the nature, and the word this bhautik vigyan, this normally used in Hindi and Gujarati, this is related to science of physical world, and it is derived from Sanskrit word called bhautiki. This bhautik vigyan has come from bhautiki. So science of knowing, understanding, studying the basic law of nature and their effects or manifestation in different natural phenomena is physics. We are very curious about what is going around us, and because of this curiosity, we have always observed physical environment carefully. We wanted to search for meaningful patterns, the relation in natural phenomena, and this is continued. This will continue forever. And the conclusion we draw, the facts and theories we derive, these are all attempts in physics. So this English word physics, this has come from Greek word understanding to be nature. When teacher comes to your class, we are talking about physics, scope and excitement, then he says something. Now a sound is produced, and when a teacher is speaking, this sound is propagating in the class, and this comes into your ears, or your ear receives it. So there are so many things which make it possible in the nature for us to live, for us to understand. So have you thought about the annual cycle of the seasons, the eclipse, the tides, the day and night, how day and night are being formed, the bright celestial object in the night sky like the stars? In physics, the use of mathematics is very prominent, very widespread. The mathematical stories or theories, the formulas and mathematical models, these are inseparable from physics. Somebody said that physics is the kind of science while mathematics is queen. Physics is king of science while mathematics is queen. So whenever we want to do something or pose something or prove something, we cannot just state. We have to mathematically prove it. So the mathematical expression obtained for some physical event, any physical event, it also provide the logical explanation of that event, but also make predictions about how other connected events may have occurred. Our physical facilities, from the time the life has come to the earth, mostly are understood by the physics. In physics, first is we not only observe these physical events, what are going on day by day, but we also want to find out definite mechanism, and this mechanism from the series of systematic observations, experiments. The quantities involved in such events, they need to be unambiguous. They cannot say two things at the same time. They need to be meaningful. And in order to derive laws or principles from such studies, and such derived laws or principles are to be tested, they can't just be said that they are laws and principles if they are not tested in wide perspectives. So physics involves study of two fundamental constituents of the universe. One is matter, one is radiation. And the physics also involves finding out the origin of fundamental particles of matter and radiation, the interaction between them, and the laws of the nature related to them, and they govern them. If we start thinking about matter, then we think about an atom. Atom has a nucleus. Nucleus has proton, and neutron, then electrons are outside. And this proton, neutron, also we have one more thing, which is meson. So there is an interaction going on. The energies of the nucleus with radius order 10 to the power minus 14 meter. This is formed due to such interactions, and the radiation which is emitted due to intranuclear transitions. These are also the subject matter of nuclear physics. If some of you goes to, or they become interested in nuclear physics, this is the interest. So electron is revolving around the nucleus in specific orbit around 10 to the power minus 10 meter with specific numbers K, L, M, N. Electronic configuration like 28, 282, like this. Their transitions, their interactions, and special properties of atom because of electrons, they are all included in physics. So when there is an interaction among atoms, the molecules are formed. So atoms combine, they form the molecule. And these atoms do not remain stationary inside a molecule, but simultaneously they perform rotational and vibrational motions. So when we study the radiations which are emitted by atoms and molecules, we get the insight of their structure. And from the physics itself, various aspects of chemistry is also understood. When many molecules and atoms they combine together, they form matter, and the matter can be gas, liquid, or solid, depending upon in which physical conditions they are. And under certain temperature and condition, we have fourth state of matter, which is plasma. Plasma is the fourth state of matter. So the plasma state of matter obtained at extreme high temperature, this has opened up possibilities as a future source of tremendous energy for us, for the mankind. So the mechanical, thermal, electrical, magnetic, optical properties of a matter are the subject matter of physics. So physics also concerned with or contains the subdiscipline like the mechanics, the thermodynamics, the electromagnetics, the optics, the electrodynamics. These are all being developed. So mechanics is based on Newton's laws of motion and law of gravitation. So this mechanics is concerned with the motion of particle, rigid and deformable bodies, force and work. The electrodynamics deals with the electric and magnetic phenomena. That is why it is electrodynamics associated with the charge and magnetic bodies. We cannot forget the contribution of physicists like Coulomb, Oersted, Ampere, Faraday, Maxwell. We should salute them. The working of optical fiber, telescope, microscope. Also the colored exhibit by thin films, rainbow, mirage. The images formed by the mirrors and lenses. They are explained in again one of the subdisciplines of physics, which is called optics. And thermodynamics, they include changes in the internal energy, the temperature, the entropy of the system through external work, or say some transfer of heat or energy, the efficiency of heat engines, the refrigerator you have, the direction of physical and chemical properties of process. They are studied in again one of the very important branch of physics, which is the thermodynamics. In physics, we discuss a space having infinite dimensions. Space with infinite dimensions. So the operators in quantum mechanics, this is also a very important field. In such a space and their operations or vectors, these are also exciting to many of the physicists. But this is not end. Physics is all over. Studies related to sun, the planetary system is also carried out in physics. The galaxies, their structure, the long distance of the order of billion light years amongst them, the distribution of billions of kilograms of their matter, the intergalactic space, the birth, the evolution, and the death of various stars. These are studied in again one of the branch of physics, which is known as astrophysics. So the span of physics goes from vacuum to infinity. Even vacuum is also considered as a definite state in physics. So something is not there, there is something then. So the scope of physics on the length scale is very, very, very small length of 10 to the power minus 14 meter, which is the radius of the nucleus, to 10 to the power 26 meter, which is the length of galaxies. So the length scales, or the factor of length scales, of the order of 10 to the power 40, and the range of time scale about 10 to the power minus 22 second to 10 to the power 18 second, and this can be obtained by dividing the length scale by the speed of light, 3 into 10 to the power 8 meter per second. The range of mass varies from 10 to the power minus 30, which is very less mass of an electron, or it can be mass of known observable universe. It can go up to 10 to the power 55 kg. So let us see a table which shows the range of fundamental physical quantities of length, time and mass. This is about the length. So this is the order of length scale for different objects. Height of a human, let us say it's 10 to the power 0. So these are the order of length scale. Radius of proton, 10 to the power minus 15. Distance of boundary of observable universe, 10 to the power 24 meter. So radius, this is in increasing order. Radius of proton, then comes radius of atomic nucleus, then the size of hydrogen atom, then thickness of paper, height of human, height of Mount Everest above sea level, the radius of Earth, the distance of Sun from Earth, the size of our galaxy, and finally distance to the boundary of observable universe. This is the order of the time interval for various events. Lifespan of most unstable particle, very less, can't even predict, can't even think, 10 to the power minus 24 seconds. Time required for light to cross a nuclear distance, 10 to the power minus 22. Period of atomic vibrations, 10 to the power minus 15. Period of sound wave, 10 to the power minus 3. Wink of an eye, 10 to the power minus 1. Time between successive human heartbeat, 10 to the power 0. Rotation period of Earth, 10 to the power 5. Revolution of period of Earth around Sun, 10 to the power 7. Average human lifespan, 10 to the power 9. And age of the universe, 10 to the power 17 seconds. And this is the mass scale. This is the mass scale. So electron, 10 to the power minus 30 kg. You can't even imagine how less this is. Proton, dust particle, mosquito, grape, then human, Earth, Sun, Milky Way, galaxy observable universe, 10 to the power 55 kg. So the scope of physics, it extends to two basic domains, very interesting. Macroscopic, that is very large, to microscopic, very small. Along with this, if something is static, not moving, and dynamic, always moving, this also covers, our scope of physics covers static and dynamic systems. So the physics is associated with time, matter and energy. Normal event, just like object falling on the earth, for a free fall flight of a balloon filled with say light gas from the earth, sinking of a pin or a needle of water, or while floating of a ship on a water. And there are more advanced projects. We know about LHC, Large Hadron Collider, the ITER, International Thermonuclear Experimental Reactor, and Moon mission. This attract us toward the study of physics. There are certain Indian physicists, internationally famous, who has given a lot to physics. Sir C.V. Raman, J.C. Bose, M.N. Saha, Homi Bhabha, S.N. Bose, Vikram Sarabhai, S. Chandrasekhar. These are just few names. There are so many who has given us what we have now. So there are certain institutes, if you guys are interested in physics, and you must be aware of these places. BARC, Bhabha Atomic Research Center, PRL Physics Research Laboratory, the IPR Institute of Plasma Research, Institute of Physics IOP, NPL National Physics Laboratory, IUCAA Inter-University Consortium for Astronomy and Astrophysics, Indian Institute of Sciences, Raman Research Institute, Tata Institute of Fundamental Research TIFR, the Center for Advanced Technology CAT, the Nuclear Science Center NSC, Indira Gandhi Center for Atomic Research IGCAR, then Indira Gandhi Center for Atomic Research, then Saha Institute of Nuclear Physics, Regional Research Laboratory, Inter-University Accelerator Center, Variable Energy Cyclotron Center, Vikram Sarabhai Space Center, Indian Institute of Astrophysics, Indian Institute of Geomagnetism, ISRO, Indian Space Research Organization. Then space research goes in Space Application Center, IITs, so many IITs, so many NITs, various universities we have. all working in the field of physics. Physics, technology, and society. We can reach anywhere now in few hours. We can talk to anyone. You can see them you can feel them, means you can feel that they are with you. While sitting at a home, you can watch the live telecast of the game at any corner of the world which is going on. We can take photographs of solar system and galaxies. These are possible because we know physics. The progress which is made in transportation vehicle, right from the invention of wheel to bullock cart, cycle, motor car, then ship, then aeroplane. In telecommunication, telegram, telephone, mobile, satellite phone. And entertainment, tape, recorder, television, heater, kerosene stove, gas stove, microwave, oven. These are used in kitchen to make our life simple. They have become possible because of the proper use of law and theories of physics in technology and actually realizing them in certain products. So it is physics who has introduced us to the radiation and also make us know how the acceleration of charged particles are going on. The physics gave instrument based on ultrasonic and optic fibers. Very useful medical technology like the X-ray, the sonography, the ECG, electrocardiograph, the ESR, electrospin resonance, the NMR, nuclear magnetic resonance, endoscopy to check what is going on inside your stomach. So these are also due to physics. The instrument like the microscope, the EM, electron microscope, the AFM, atomic force microscope, they're also playing a vital role in the development of material technology, nanotechnology, and biotechnology. There are certain space technology, rocket, missile, space shuttle, man-made satellite, remote sensing. These are also commonly used. The lasers, the radars, microwaves, another science which is related to physics. Physics has also made us know the technique of achieving very low temperature, which results in development of cryogenics. Physics can be called as the mother of subjects like the electronics and the communication and the computer technology, also the IT, information technology. But even after this tremendous development, we are still in the process of learning physics. Many problems physicists are still pondering upon, they are working on it. For example, does universe consist of single matter? Are matter and energy two different aspects of the same thing? Is unification of various forces in nature possible? And what will be the future of universe? We don't know that. So forced with all these questions, physicists are attempting to solve two principal thrust or stimulus in physics, unification. And now the fundamental forces in nature. And just take an example that when we roll a ball, we have to apply a force, and after some time, this ball, after traveling certain distance, because of some force, frictional force, this force will stop this ball. So we have to use a force to lift a ball from surface, and if somebody pulls you or pushes you, you will feel some or the other force. So these forces are experienced day-to-day life, and starting from the very basic concept of force, we may learn the scientific concept of force. Isaac Newton, he was the first physicist who developed clear concept of force in his famous laws of motion. He also discovered the universal law of gravitation. If you take the very large, huge macroscopic domain, beside this gravitational force, there are certain forces like the frictional force, the restoring force, that is in a compressed string, the tension which is produced in a stretched string, the force of surface tension which is on the free surface of a liquid, the viscous force in fluid medium, they all are there. And apart from these forces, a force is also generated because of electricity or electrically charged and magnetic objects. So electric and magnetic forces, nuclear forces, interatomic and intermolecular forces, these are the examples of force which are prevailing in very small, that is microscopic domain. So let us understand them qualitatively. Gravitational force. So the gravitational force is a universal force that is exerted on every object. Every object experiences this force due to every other object in the universe. According to Newton's law of gravitation, the mutual force is directly proportional to the product of the masses. Say m1, these two are objects. So m1 is the mass of this one and m2 is the mass of this one. So this is directly proportional to the product of masses and inversely proportional to the square of the distance between them. So this gravitational forces is because of the mutual attraction between any two objects because of the virtue of their masses. It's a long range force and it does not require any intervening medium. There is no medium required. When you compare this gravitational force with others, this is the weakest force of nature, but very important phenomena because large portion of physical phenomena in the universe is held by this force. And because of this gravitational force, we are able to stand on the earth. The ball which we throw comes back to us again. Even the tides in the sea, they are believed they are caused due to the gravitational force between earth and moon. And the effect of this gravitation of earth and moon, so this is the result giving into tides. So the effect of gravitational force cannot be neglected. Why? We cannot neglect it because neglected in the phenomena like the motion of satellite around the earth, motion of the planet around the earth, formation of universe, formation of and evolution of stars and galaxies, they all have one thing in common, that there is some force which is the gravitational force between the two objects which is acting upon them. Now we come to electromagnetic force. There are charged particles. So the force acting between these charged particles, we know it as electromagnetic force. If we take very simple case, when charged particles are at rest, the force between them is known as static electric force. So the magnitude of this electromagnetic force, or you can say this force, obeys Coulomb's inverse square law. So the force between two electric charges is directly proportional to the product of the charges Q1, Q2 and inversely proportional to the distance between them. And if we have like charges, the force is repulsive. If the charges are unlike, the force is attractive. When the charges are static, we have seen, but when they are in motion, they will produce magnetic effects. So this magnetic field gives rise to the force on the moving charge. What is the intensity? The intensity of magnetic force get changed because of the motion of charged particle. So when we combine them, that is the combined effect of electric and magnetic field is in general it cannot be separated. That is why they are inseparable. So the combined effect of this force is known as electromagnetic force. So electromagnetic force between two objects also depends on the medium prevailing between them, and as you can say that like the gravitational force, electromagnetic force is also a long range force and does not require any medium. Very strong compared to gravitational force, very strong. The electric force between two stationary proton, for example, is 10 to the power 36 times the gravitational force between them. You can just imagine the power, or you can see the comparison between these two forces for any distance. So the effect of electromagnetic force you can see in lightning in the sky, electric bell, etc. We have two forces, strong nuclear force and weak nuclear force. So we know that the nucleus is made up of what? We have, if this is a nucleus, we have proton, we have neutron, right? So proton is positively charged while neutron has no charge. They are chargeless. But if we think of a Coulomb law, then the repulsive force which is acting between these charged particle proton and the nucleus, that is it is going to make it unstable. This indicates us that within the nucleus there must exist a strong attractive force which is binding this proton and neutron together. So the charge independent force acting between proton-proton, proton-neutron and neutron-neutron within the nucleus is known as strong nuclear force. Actually, the force is 100 times stronger than the EMF, electromagnetic force. And this force exists within the nucleus. This is the nucleus. So it's a short range, that is around 10 to the power minus 15 meter force. And the strong nuclear force is the strongest of all the fundamental forces we know. So neutron and proton, they are thought of as being made up of fundamental particle which is known as quark. In the recent research, the force is believed to be a quark-quark force. And just to note that electrons are outside the nucleus, so the strong nuclear force does not act on them. Now we come to weak nuclear force. So this weak nuclear force, this appears only in certain nuclear processes. For example, beta decay of radioactive nucleus. In this beta decay, the nucleus emits an electron and a chargeless particle which is called the neutrino. So electron and neutrino. So the weak nuclear force, it arises due to the interaction between the neutrino and other particles. The force is stronger than the gravitational force, but it is weaker than the strong nuclear force and also weaker than the EMF, electromagnetic force. The range of weak nuclear force is of the order of 10 to the power minus 15 meter. Now the thing comes as unification of forces. We'll see in a table the fundamental forces of nature, their range, their relative strength. So, so many years have gone, physicists are still thinking of one question. Do all these fundamental forces, they come from a single force? One more question. Can all fundamental forces be explained from the hypothesis of a single force? So we have attempts to explore these ideas, and this is open for unification of processes or unification of different forces. So this is the table I was talking about. These are the fundamental forces in nature. We have gravitational force, which is the relative strength is from this one. Strong nuclear force is 1. So the relative strength from 1 is 10 to the power minus 38. The range is infinite. All objects in the universe experience it. The weak nuclear force is relative strength having 10 to the power minus 13. Very short, within the nucleus only. Similar is the strong nuclear force, again very short, within the nucleus. It is given as 1. And this is between, weak nuclear force is between neutrino, elementary particles, and strong nuclear force is between nucleons, neutrons and protons. When it comes to EMF, electromagnetic force, it is relative strength having 10 to the power minus 2 as compared to this. It is also between two objects infinite distance, and this is only between charged particles. So Newton has unified terrestrial and celestial domain, and this came under the common law of gravitation. Again, Oersted and Faraday, they showed that electric and magnetic phenomena are in general, they cannot be separated. Then Maxwell, he unified electromagnetism and optics with the discovery that light is an electromagnetic wave. Then Einstein attempted to unify this gravitational force with electromagnetic force but could not succeed. Then Glashow, Salam, Weinberg, they showed that the weak nuclear force and the electromagnetic force can be viewed as a different aspect of a single electro-weak force. And efforts are still going on for the unification of fundamental forces. So let us see what we have just discussed, that this is the progress in unification of different forces. Isaac Newton started in 1687. He unified celestial and terrestrial mechanics. He showed that same laws of motion and the law of gravitation apply to both the domains, celestial and terrestrial. Then Oersted and Faraday, he in 1820, Faraday in 1830, what they achieved in terms of unification is electric and magnetic phenomena, they are inseparable aspect of unified domain, which is electromagnetism. Then Maxwell 1873, he unified electricity with magnetism and optics, and he showed it by showing that light is essentially an electromagnetic wave. Then Glasgow, Salam and Weinberg in 1979, they show that weak nuclear force and the electron magnetic force could be viewed as different aspects of single electroweak force. Rubia and Meir 1984, they actually did the verification, that is experimental verification of the theory of electromagnetic or electroweak force. So there are certain nature of physical laws. Any physical phenomena is governed by different forces. There are several physical quantities. This may change with time, but there are certain quantities, physical quantities, that will not change, that will remain constant with time. So the physical quantity that will remain constant with time or that will not change, we call it as conserved quantity. Or in other terms, the conservation of some physical quantity. This means that quantity does not change with time. So the law of conservation of energy, charge, linear momentum, angular momentum, these are considered as the fundamental laws of physics. So the basic law of conservation, it also plays important basic role in physics. So what are the laws? The law of conservation of energy. The amount of total energy in the universe remains constant. Energy can neither be created nor be destroyed. It can just be transformed or converted from one form to another. Like the mechanical energy can be converted into electrical energy in this way. Law of conservation of charge. During any process taking in an electrically isolated system, the algebraic sum of the charges always remain constant. This is law of conservation of charge. Then comes the law of conservation of linear momentum. If the resultant external force on any system is zero, then total linear momentum of the system remain constant. Then comes the law of conservation of angular momentum. This says if the resultant external torque, we'll talk about this, acting on a system is zero, then the angular momentum of the system remain constant, right? So we are going to see them in detail, but there are things, in addition to these four laws, we have law of conservation for spin, baryon numbers, strangeness, hypercharge in nuclear and particle physics. So the now same question arises, in which tacit form the nature is responsible for the existence of law of conservation. In physics, the studies are still going on or is carried out of space and time in terms of space and time. So in classical mechanics, space and time are considered independent of each other. While when we come to theory of relativity, this says, actually proposed by Einstein, space and time, they are interrelated. Space is homogeneous and isotropic, because of which we have the law of conservation of linear momentum, law of conservation of angular momentum. So the time is also homogeneous and isotropic, and because of the homogeneity of time, we have law of conservation of energy. But till today, the physicists, they are unable to know what will be the possible result due to isotropicity of time. Dirac, the great theoretical physicist of 20th century, Dirac, he gave an opinion that the law of conservation of charge may be due to isotropic nature of time. So what we want to say here is, we know the basic reason behind the existence of law of conservation of linear momentum, angular momentum and energy. But physicists are still working out, revealing the underlying mystery of nature in the laws of conservation of charge. So this is for you also. You can think upon it and you can work upon it. Physical world. The word Bhautik Vigyan, which is used in Hindi and Gujarati, these are related to the science of physical world derived from the Sanskrit word which is called as Bhautiki. That is why this is Bhautik Vigyan, which is physics. So English word physics has come from Greek word that means nature. We know that physics is all about nature. So physics deal with the study of basic law of nature related to matter, energy and their effect or manifestation in different phenomena. The scope of physics is extended to two basic domains: very large macroscopic or very small microscopic. It also deals with something which is standing, that is static, or always moving dynamic system. Basic law of physics are universal and they apply in widely different contexts of conditions. The gravitational force, electromagnetic force, strong nuclear force and weak nuclear force, these are the four fundamental forces in nature, and there are attempts going on for unification of these four forces. The physical quantity that remain unchanged with time, we call it as conserved quantity. The law of conservation of energy, charge, linear momentum and angular momentum, these are considered as the fundamental laws of physics. Dash are two fundamental constituents of universe. What is the answer? Matter and radiation. Dash is the fourth state of matter, plasma. Nucleus of molecule is made up of which fundamental constituents? Nucleus. It is made up of proton and neutron. What is the acronym of ECG? Electrocardiograph. C is the correct answer. What is the full form of NMR? Nuclear magnetic resonance. What is the full form of ESR? This is electron spin resonance. The force exerting between neutron and proton within the nucleus is known as strong nuclear force. Which particle are emitted during beta decay from the nucleus? This is electron and neutrino. Space is isotropic. Which law of conservation is the result of this? Space is isotropic. The answer is law of conservation of angular momentum. Space is homogeneous. Which law of conservation is the result of this? The answer is law of conservation of linear momentum. Time is homogeneous. Which law of conservation is the result of this? Time is homogeneous. So the answer is law of conservation of energy. The basic reason behind existence of which conservation of law is still not known. The answer is law of conservation of charge. So these are the questions. Please try. I'm going to answer this in the next discussion. Till then, thank you so much and take care of yourself.